Okay, today we will discuss the conventional symbols for some common components, that is electrical components. Okay, first is an electric cell. So this is the symbol of an electric cell, one bigger line and one smaller line. The bigger line shows the positive terminal and that smaller line shows the negative terminal. Second is a battery or combination of cells. So this is the symbol of a battery. It is the group of cells. Combination of cells is called the battery. We can show the battery by this symbol or by this symbol. The third is plug, key or switch. The switches we use in home or in the laboratories. The plug, key or switch when it is open or when the switch is off. So when the switch is off, so this is the symbol of when plug key is open. These two are symbols of plug key in the open condition. Okay, next is plug key or switch is closed, or we can say switch is on. So this is the symbol for closed plug key. Next is a wire joint. Now consider there are two wires and they are joining at a point. So we show the joint by this diagram or by this symbol. Okay, next is wires crossing without joining, because it's a two-dimensional page. So we cannot show the two wires if the two wires are crossing each other. So we can see them three-dimensionally, but on the two-dimension page, we can show these two by this diagram. Okay, next is an electric bulb. So this is the symbol of electric bulb. Next, a resistance. Okay, a resistance is the obstruction or the hindrance offered to a conductor to the flow of electric current. That is anything which stops the flow or resists the flow of current through a conductor. That is called resistance. So if the resistance is fixed, if the value of that resistance is fixed, we can show the resistance by this symbol. And if the resistance is variable or rheostat. Okay, rheostat is a device used in the laboratory to offer the variable resistance in the circuit. So we can show the variable resistance or the rheostat by these two symbols. Okay, next is an ammeter. Okay, an ammeter is a device to measure the electric current. So this is the symbol of ammeter. Next is a voltmeter. Voltmeter is a device to measure the potential difference. So this is the symbol of voltmeter. Okay, next is a galvanometer. Galvanometer is a device to check the presence of electric current in a circuit. We can also use ammeter in this, but galvanometer used to show the slight variation or the slight presence of current which is not able to detect by the ammeter. If there is a slightest current in the circuit, so we can detect it with the help of a galvanometer, and we also find out the direction of the current with the help of a galvanometer. Okay, there is a question based on these electrical components. We'll do it afterwards. First, we'll do the topic electrical resistance. Okay, electrical resistance. Resist means to stop. So what does it stop? It stops the electric current or tries to stop. It's not that it stops all the current. It tries to stop the current, or it offers the hindrance to the flow of current. The obstruction offered by a conductor to the flow of electric current is called electrical resistance. Its SI unit is ohm, OHM. SI unit is ohm, denoted by this symbol. So there are some factors affecting the resistance. First factor is nature of the conductor. Nature means the material of which the conductor is made. It's a good conductor of electricity or the bad conductor of electricity or the moderate conductor of electricity. So that resistance depends on the nature of the conductor. The second factor is length of the conductor. Resistance is directly proportional to the length of the conductor. More the length of the conductor, more will be its resistance. That is R denotes the resistance of the conductor and L denotes the length of the conductor. So R is directly proportional to L. This is called law of length. Okay, next factor is area of cross section of conductor. inversely proportional to area of cross section. That is, resistance of conductor is inversely proportional to area of cross section. That is, this is called law of area of cross section. Next factor is temperature of conductor. Resistance increases with increase in temperature. We don't have the direct relation that it is directly proportional. No, it's not directly proportional, but in some fraction that resistance increases with increase in temperature. We don't have that relation, direct relation we don't have. So combining these two equations, because these two are direct relations, that we know that it is directly proportional and it is inversely proportional. These are fixed. So combining these two equations, from equation 1 and 2, R is proportional to L by A. R is proportional to L comes from the first equation, and R is proportional to 1 by A comes from the second equation, and we have combined these two equations. So R is proportional to L by A. Removing the sign of proportionality, we introduced a constant. R is equal to, this constant is called rho, R-O-W, rho, or RHO, 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 rho. This constant is called rho. The name of this constant is called rho. Now rho is the constant of proportionality called resistivity or specific resistance. That means the meaning of this constant is resistivity or specific resistance. Specific, now we'll define the specific resistance or resistivity. From the formula of resistance, we know that R is equal to rho L by A, or rho is equal to R A by L. Now if we consider that area of cross section of the conductor is 1 meter square and the length of the conductor is 1 meter, then rho is equal to R. So we can define the rho or the resistivity in this way. That is, resistivity can be defined as the resistance of a conductor having unit area of cross section and unit length. Resistivity can be defined as the resistance of a conductor having unit area of cross section and unit length. Now we'll find out the SI unit of resistivity. From the formula we know that rho is equal to RA by L. Now the SI unit of R is ohm, area is in meter square, and length in meter. From 1 meter and 1 meter from above, that two are cancelled out or rationalized, then we have rho meter. So the SI unit of resistivity is ohm meter. Okay, next we'll have factors on which resistivity depends. Okay, in the formula we have resistance, area and length, but rho doesn't depend on, these are present in the formula of resistivity, but resistivity does not depend on all these factors. Resistivity depends only on two factors. First is nature of the conductor, and second is temperature of the conductor. Rho depends only on these two factors and not on all these factors. If we increase the length or decrease the length, if the area of cross section has been changed, there is no effect on resistivity. Resistivity only depends on the nature and the temperature of the conductor.